again, for this example, we want to determine the equation of a quadratic function when given the graph. Now, because we don't know the vertex, we are actually going to use standard form, the standard form equation for this problem. We could probably guess what the vertex is based on where it's located, but we want to be precise, and so we're going to use standard form. So in order to write our equation in standard form, we have to figure out what A, B, and C are. And we're going to use these 3 points to substitute in for the values of x and f of x to solve these equations for A, B, and C. So the first point that I'm going to use is the point 0, -1, because with the x-coordinate of 0, that's going to eliminate these 2 values, and I'm actually going to be able to solve for C from the very beginning. So we know that this value is just the same as our f of x value, because our f of x is just y. So we use the point 0, -1. We're going to substitute this into our function. So we have -1 equals a times 0 squared plus b times 0 plus c. So we see that from this, a times 0 squared, that's just going to be 0. B times 0 is just 0. So from this, we get -1 is equal to c. So we found our first value. We know that c is -1. We're going to use this fact and substitute into here along with one of our other points to try and hopefully find the values of a and b, or at least give us a simpler equation so that we can use systems to solve. So I'm going to use this first point here. This first point here, 3, 5. So 3, 5. So 5 is the value of f of x. So 5 equals a times 3 squared plus b times 3 plus c, but we know c is -1, so -1. And then simplify. So 3 squared, that's 9. So this is 5 equals 9a plus 3b minus 1. We can add this 1 to both sides so that we get from this 6 equals 9a plus 3b. So now we have an equation in just 2 variables, so hopefully we can use this to solve using systems of equations. And let's use this last point, plug it in, and hopefully get another equation that we can use to solve. So -1, 5. So we have 5 equals a times -1 squared plus b times -1 plus c, which is -1. -1 squared is +1. So we have 5 equals a times +1 is just a. B times -1 is a -b minus 1. Again, we can add 1 to both sides, and from this we get 6 is equal to a minus b. So now we have 2 equations, and it's actually pretty nice because these 2 equations are both in terms of the same variables. They're both in terms of a and b, and they're actually both equal to 6, which means we can just set those 2 equations equal to each other. We can use substitution to solve these. So we have a minus b equals 9a plus 3b. And then do some addition and subtraction. So subtract 9a and add b to both sides, and we will have -8a equals, and then add b for b. Solve for b so we can divide by 4, and we get from this that -2a is equal to b. -2a is equal to b. Now, again, we have to do more substitution, but this helps us. We can now take one of these equations that we have and just write them in terms of a single variable to solve. So if I take this and I substitute it in here, right, I can substitute in for the value of b to solve this equation for a. So we have 6 equals a minus b, but b is negative 2a. So when we subtract a negative, we know that that makes this addition. So we have 6 equals a plus 2a, which is 3a. And you divide and you get that a is 2. And last bit of substitution, so we know that a is 2. We found our second value. So we know c is negative 1, we know a is 2. To figure out our last value, which is b, we just take 2 and substitute it in here. So negative 2 times 2 is going to be b, so negative 4 is equal to b. And we found the last value for standard form. So now our last step is to just put all of this together to write our equation. So we have our equation is f of x equals a, which is 2, x squared plus bx, so that's minus 4x, plus c, which is negative 1. So this is our equation of this graph in standard form.